See, ma'am. So now this diagram is diagram of potentiometer, ma'am. So these are two metal rods or anything you can call them. Basically these are two conductors only, ma'am. Okay, so this is a conductor and this is also a conductor. Okay, so in between these two conductors we are placing one wire, and length of the wire, it varies. Length of P wire means potentiometer wire, it varies from 1 meter to 5 meters. So generally it will be 5 meters, but in small potentiometers it will be of length 1 meter also. So 1 meter to 5 meters length of potentiometer wire. Okay, ma'am? And this wire is given a small supply voltage also. It varies from 2 volts, 4 volts, 6 volts, like that. Okay, and here there is a rheostat also. What is meant by rheostat? Rheostat is an instrument where resistance can be varied. Okay, ma? See, ma, if you take this jockey and if you place the jockey here, then very small resistance is introduced in the circuit, no? Clear, no? Because the length of resistor is very less. So this indicates resistance, ma. Clear? If I connect a jockey here, then only this much of resistance is introduced. And if I place the jockey somewhere here, it means total resistance is introduced in the circuit. So rheostat, what rheostat does? It varies the resistance. Okay, ma? It varies the resistance. So what is the required amount of resistance that this potentiometer rheostat will do? Okay. So therefore, see, ma'am, if I give a supply, let us take an example, and we will take an example and we will try to understand how this potentiometer works. So let us consider supply voltage is 2 volts. Supply voltage is how much, ma'am? 2 volts. And let us consider length of the wire is 1 meter. Let us take length of P wire, potentiometer wire is 1 meter. Okay. Then this 2 volts will completely gets dropped in this wire. Are you able to understand, ma? And these are just small lengths only, no? This one and this one is very small length. You can neglect the resistance of remaining wire. So total supply potential of 2 volts will get dropped in this wire. Because any wire will have some resistance, no? Even if it is a conductor also, it will have some resistance. And what resistance will do? It consumes the voltage. Are you able to understand, ma? So therefore what I say, total supply potential is consumed by whom? Is consumed by P wire, potentiometer wire. Are you able to understand? So it means starting from here up to here, total length of the wire consumes this 2 volts of potential. Now see. Now we will study a term which is called as potential gradient. Potential gradient. Okay, ma? It is given by the symbol K. What is meant by potential gradient? How much of potential is consumed per unit length of the wire? That is called as potential gradient. V by L. V is called supply voltage. L is called total length of the wire. Are you able to understand? It means per unit length of the wire, how much potential will be consumed. For example, if I take 1 centimeter of wire, 1 centimeter of potentiometer wire will consume how much potential? So total 1 meter will consume 2 volts. That is okay. Total 1 meter of wire will consume 2 volts. But if I take only 1 centimeter of wire, this 1 centimeter will consume how much voltage? That ratio is called as potential gradient. Okay. So what is the total supply potential I have given? 2. What is the total length of the wire? 100 centimeters. 1 meter means 100 centimeters only, no? So 2 by 100 is how much, ma? 2 by 100 is 0.02 volts per centimeter. Okay, ma? So if I got this figure, what do you understand by this figure? Can you say? What is meant by 0.02 volts per centimeter? For 1 centimeter of the wire, how much potential is consumed? 0.02. That is the meaning of this. For total 1 meter length, potential consumed is 2 volts. But for 1 centimeter of wire, potential consumed is 0.02. That is the meaning of this one. Okay. So therefore what I write, for each centimeter of potentiometer wire, potential consumed is how much, or potential drop is how much? Potential drop is 0.02 volts. That is the meaning of this. Is it clear? Therefore, for 2 centimeters, how much potential is consumed? For 2 centimeters, potential drop is how much, can you say? So 0.02 plus 0.02, 0.04 volts. Understood? No? Okay. So therefore, potential consumed or potential drop in half of the wire is how much? Potentiometer in half of the wire? 1 volt. 1 volt, that's all. That is the meaning of this one. Why it is only 1 volt? Total supply is 2, no? So in half of the wire, that is from starting from point A to point B. In between A, B, if it is half of the wire, then half of the wire will consume how much voltage? 1 volt, half voltage. Remaining half will consume remaining half. Is it clear? So this concept you should be very clear. Then only you can understand working of potentiometer. Is it clear everything? So for total 1 meter of wire, potential consumed is 2 volts. Therefore, for each centimeter, potential consumed is 0.02. Then you go and do the calculation. For 2 centimeters, how much drop? 3 centimeters, half wire. Like that you can do the calculation. Okay, ma? So for each centimeter, how much is the potential drop? That is called as K. Fine? Right up to here. Okay, ma? So therefore what we understand that potential drop in the wire, okay, ma? Potential drop in potentiometer wire depends on what? Depends on length of wire. That's all, no, ma? Can I say this point? Length. Depends on length of wire considered. Okay? If I take only very small part of the wire, then in that wire potential drop will be lesser. If I take bigger length of the wire, potential drop will be greater, like that. Are you able to understand? That's it. Okay, ma? Now let us see what is the functioning of this potentiometer, ma? How this potentiometer works. Let us see. So working principle of potentiometer. Okay, see, ma. Let us take an example and we will try to understand how we take readings with the help of potentiometer. Now see. So working we are writing now, so we will take one example. Take a cell of EMF E less than supply potential, and connect between points A and B. Okay, ma? And connect between A and B. Are you able to understand, ma? Then slide the jockey on potentiometer wire, okay, ma? Until reading in galvanometer becomes 0. Okay, so reading becomes 0 when potential drop in upper part of wire, or just you can say potential drop in potentiometer wire is equal to EMF of cell. Okay, ma? Now listen, ma. See, ma. Now let us see what is happening. See, ma. Let us try to understand working principle of this potentiometer. Or this is, you can say, application number 1. Okay? Application number 1. What is application number 1? Finding EMF of a cell. Finding EMF of a cell. We are not finding terminal potential. We are not finding terminal potential. We are finding EMF. What is EMF? Total capacity of the battery is called EMF. No? So directly we can measure EMF here without measuring terminal potential. So what we do is, Sima. So these are the 2 points A and B, which are left empty here. In between these 2 points, I will connect a battery whose potential difference I want to measure. Clear? So this cell's EMF, I don't know. I don't know what is the EMF of this cell. And I want to measure EMF of this cell. Ikkada twist endo telusa, ee diagram malli veyali meeru. For this application, this diagram you are supposed to draw. Are you able to understand? Sima. Tarvata veyandi. So EMF of this cell I want to calculate. And this EMF of the cell should be less than the supply voltage. What is the supply voltage? 2 volts. So this EMF should be 1.5, 1.7, 1.8, less than 2. Then only we can measure, otherwise we cannot measure. Okay? Now what I do is, after introducing this unknown battery, I will take this jockey and I will continuously slide on this potentiometer wire. Are you able to understand? Are you understand what is happening? I will take this jockey, I will slide on this potentiometer wire. And I will slide until which position? Until the reading of the galvanometer will show 0. Okay? So for example, let us consider, after joining the galvanometer up to here, let us call these points as point C and point D. Okay, ma'am? So jockey is connected at point D. Then I see that the reading of the galvanometer is 0. Okay? Then what do you understand? In which condition galvanometer reading will become 0? Galvanometer, what is meant by galvanometer? It measures the strength of current. Small amount of current is represented by galvanometer. Are you able to understand? So if galvanometer reading is 0, it represents that there is no current which is flowing. It represents that current is not flowing in the circuit. Are you able to understand? Current doesn't flow only when potential differences are equal. Are you able to understand? So therefore, completed now this one? So therefore, current does not flow. Current does not flow in which condition? When potential drop between CD is equal to EMF between AB. Okay, ma? When this condition is satisfied, then current doesn't flow in the circuit. What is the potential drop in this much part of the wire? If same potential is existing in this wire also, then you don't find any current. Okay? And depending on the length of the wire, I can calculate what is the potential drop in this wire, by using K value. By using a potential gradient, if I know the length of the wire, I can easily calculate how much potential drop is present in this wire. And when EMF of this branch and this branch, when they are equal, then only current doesn't flow. It means what is the potential drop existing in this points between C and D, same will be the potential of this cell also. That's all very simple. Are you able to understand? Let us take an example. Example is, let us take same 2 volts and let us consider length of potentiometer wire. Length of potentiometer wire between C and D, B. Total length is 1 meter, Nama. So potentiometer wire between C and D, let us take 65 centimeter. Okay. Then what is the EMF of the cell? Can you say, anybody? What is the length of C and D, ma? Length of C and D is how much? Length between C and D, let us take it is 65 centimeter. Okay. Supply potential is 2 volts. Now here galvanometer reading is how much? Reading of galvanometer I got how much? I got 0. Okay. Now can you say what is the EMF of this cell? 2 by 65. See, ma'am. So one point which I can say is, already we have written one point, no? Potential drop is directly proportional to length. Can I say like this? This point already we have written. Potential drop in this potentiometer wire, it is directly proportional to length. Because as length increases, the potential drop also increases. Because in total 1 meter, what is the potential drop? 2 volts. Are you able to understand? In total 1 meter of wire, potential drop is 2 volts. But here total length is not 1 meter, no, it is only 65 centimeter. So potential drop also will be less than 2 volts. And that potential drop will be exactly the EMF of the cell. Are you able to understand? And it is EMF only. Why? Because current is not flowing, no? If current is not flowing, current does not pass through the internal resistance of the cell. If there is no drop in internal resistance, it is called EMF of the cell. Yesterday we studied EMF and potential drop, no? Terminal potential. That concept also we have to use. Okay. So therefore, if this is the condition, V is directly proportional to L. Now can you say what is the potential drop between C and D? Potential drop between C and D is how much? Anybody? Come on. No. Okay, ma? So, how can I calculate? V is directly proportional to L, and the proportionality constant is V is equals to K into L. I can write like this, where K is called as terminal potential, potential gradient. Okay, ma? And what is K value? K value is total supply potential divided by total length multiplied by length between C and D. This is how I have to write now. I want a potential drop between C and D only, no? Okay. Potential drop between C and D, it is directly proportional to length between C and D. Is it clear? And what is the proportionality constant I am taking? K, potential gradient. Why I am taking K? Because K is nothing but total supply potential divided by total length. Comparison I am doing, that's it. Are you able to understand? So therefore, now do all the calculations. Potential drop between C and D is equals to total supply potential 2. Total length of the wire is 100 centimeter. Multiplied by length between C and D is 65. So 65 by 100, it is a ratio only, no? What is 65 by 100? Ratio of lengths. Ratio of lengths multiplied by total potential, proportional potential drop between C and D. This is the method which we can use. Okay. Now do the calculation. Okay, ma? So 250. Okay, ma? 5 13, sir. 5 10, sir. So 13 by 10 is 1.3 volts. That is my answer. Able to understand, ma? So potential drop between C and D is how much? 1.3. So therefore, what is the EMF of the battery which we have connected? How much? EMF of the battery is also 1.3 volts. Why EMF is also 1.3? Then only galvanometer reading will become 0, no? What is the potential drop between C and D? Same potential drop should be existing in this wire also. So automatically there will not be any current flowing in the wire. Potential drop in this wire is 1.3. So therefore in this branch also potential drop will be 1.3 only. And that 1.3 is supplied by whom? By battery. Current is not flowing, no? So internal resistance does not consume any voltage. Yesterday we studied resistance of battery also, no? So battery will consume voltage in which condition? Battery will consume its own voltage in which condition? Only when current flows. గుర్తున్నా ఇవన్నీ ఎప్పుడో నిన్న చెప్పింది ఇంకేం గుర్తుంటాయి అన్నట్టున్నారు మీరు. When only current flows, then only battery will consume its own voltage. Is current flowing? No. Then only reading is 0. No? If current is not flowing, EMF does not reduce. EMF remains to be 1.3 only. If current flows, then it will be less than 1.3. Is it clear? That's it. Write down. Okay, ma? So this is the equation which you should remember, ma. Potential drop between 2 points is directly proportional to length. And what is that proportionality constant? That proportionality constant is K. Where K is total potential divided by total length. Is it clear? That's all. Okay. Now see, now we are, see, listen carefully. Now we are studying the second application of potentiometer. In the first application, we have studied how to find out EMF of an unknown battery. No? Now we are trying to compare EMF of two cells. So these EMFs I don't know. What is the EMF of first cell, second cell, I don't know. Okay. So I am connecting them in parallel, and there are two switches also. So there is a galvanometer, there is a jockey, which can slide on this potentiometer wire. Okay. Now first what I will do is, I will close this switch S1. I will close this switch. Okay. This is in open only. Second switch is in open condition. First switch is closed. If I close the first switch, then in the circuit, E1 will come into circuit. No? E1 will enter into circuit no, because switch is closed. But E2 is out of circuit. Are you able to understand? Because this is an open circuit no, there is no concept of E2. E2 is out of circuit. E1 is present inside the circuit. So what I will do is, I will take this jockey and I will start sliding on the potentiometer wire. So wherever I get galvanometer reading to be 0, that length I will call it as L1. Okay. For example, let us consider I got, when I connected a jockey here, I got galvanometer reading to be how much? Galvanometer reading, I got 0. So what is this length called? This length is called as L1. Okay. And depending on L1, the EMF of this battery will be decided. No? Are you able to understand? Ma? So even if it is very large, then EMF of the cell also will be very large. Yesterday only, in the last application only we have done, no? So if EMF of this cell is greater, length also will be greater. So therefore what I can write? E1 is directly proportional to L1. So length where you got a null point. A null point means what? Null point means that point where you get reading of the galvanometer to be 0. That is called as null point. And what is the proportionality constant? K. K is potential gradient. So E1 is K into L1. First step. Then what I do is, I will open this switch S1 and I will close this switch S2. Are you able to understand? Now which battery is in circuit, which is out of circuit? E2 is present inside the circuit, E1 is out of the circuit because it is open. Current doesn't flow here. Okay. Now again you search for null point. So let us consider I got a second null point somewhere up to here. So this length I will call to be L2. Okay. So definitely I can say E2 is directly proportional to L2. So again E2 is equals to K into L2. Now how to compare them? Just divide them. Okay. So dividing 1 by 2. Then what I will get? E1 by E2 is equals to KL1 divided by KL2. K get cancelled. So therefore E1 by E2 is equals to L1 by L2. So this is how I can compare the EMFs of two cells. I am not finding EMF. I am just comparing the EMF. So many times questions were asked directly on this relation. Comparing the EMF of two cells. Okay? Right. Okay. Sim. So third application, last application of potentiometer is finding the internal resistance of any cell. Okay. So this is the cell which we have taken, and this is its internal resistance R. And there is one external resistance also, capital R, and there are two switches S1 and S2. This is the construction. Now see now. So what I do is, I will first close this switch S1 and I will search for null point. And let us consider I got null point somewhere here. I got null point at L1. Okay. Now because I am searching for null point, now this length L1, will it represent EMF of the cell or will it represent terminal potential of the cell? Can you say? I am closing switch S1. Switch S2 is in open condition. I am searching for null point. I got null point at L1. Now this L1, will it represent EMF of the cell or will it represent terminal potential of the cell? EMF. How can you say? Current is 0. So in this reading, in this galvanometer reading will be how much? 0. Okay. So this length L1 represents EMF of the cell. So therefore what is the statement I can write? E is directly proportional to L1 or E is equal to K into L. This is what I can write now. Okay. Now see. Now what I am doing is, now I am closing both the switches. S1 is also closed, S2 is also closed. Now again I will search for null point. Now I got null point somewhere at a length of L2. I got up to here. Okay, ma? So this length is L2. Now what does this L2 represent? Now again reading is 0. When I close L1 and L2, I got a null point at L2. Sorry, when I close switches S1 and S2, I got null point at L2. Now L2 represents what? Will it represent EMF of the cell, or will it represent terminal potential of the cell? That would be EMF, terminal potential. How can you say? Anybody? See, my L2 definitely represents terminal potential of the cell, but how can you say? See, when both the switches are closed, current will not flow in galvanometer, but current will flow in this branch, no? Now this is a closed circuit, no? A, B, C, D will behave like a circuit. Are you able to understand? So switch S1 is also closed, switch S2 is also closed, no? Now this total circuit, this is a closed circuit, no? Which circuit I am saying? A, B, C, D circuit is a closed circuit. And who is the supply potential here? EMF. This is the battery, supply battery, no? And what is the total resistance? Small r plus capital R. These two resistors, they are in series only, no? What is this small r? Internal resistance of the cell. What is this capital R? External resistance. Are these two in series or in parallel? Yatla parallel. Same current will, see, if here I current is flowing, same I current will enter into this resistor also, no? Current, is it getting divided? No. So therefore this resistor and this resistor, they are in series connection. Okay. It means same current I will enter into this internal resistor also, no? Same current I will enter into internal. Current in galvanometer is 0. Okay. So this current will enter into internal resistance. So once current enters into internal resistance, here there will be some potential drop, no? Inside the internal resistance, there will be some potential drop. It means battery is consuming its own voltage. That's the concept in the battery is consuming its own voltage. If a battery is consuming its own voltage, then EMF is not existing, no? Now what is existing? Only terminal potential is present, no? Now there is no concept of EMF. So therefore, in between these 2 points A and B, which potential is present? Only terminal potential is present, EMF is not present, because current is flowing. If current doesn't flow, EMF remains to be EMF, but current is flowing, no? So there is some drop. Okay? So therefore, in between points A and B, what is the remaining voltage? Remaining voltage is only terminal voltage is present. So that is why length also reduces. Previously length was L1. This is L1. Okay. Now after connecting both switches, after joining both switches, length is only L2. L2 is less than L1. Why L2 is less than L1? Because terminal potential is less than EMF, no? In the first condition, only S1 was closed, S2 was open. So current is not flowing. If current is not flowing, total EMF is present as it is. So length was greater. Balancing length was greater. Now when I close both switches, current is flowing in this circuit. It means current enters into internal resistance also. So battery consumes its own voltage. If battery consumes its own voltage, EMF has reduced. And that reduced EMF is called terminal potential. So therefore length also has reduced. So L2 is less than L1. Is it clear? Now let us see the equations. See, when only switch S1 was closed and S2 was open, that was the condition which we got first equation. No? So what are the conditions of first equation? S1 is closed, S2 is open. Clear, no? So when S1 is closed, I get balancing length only for EMF of the cell. No? I get balancing length at length L1. Okay, ma? So EMF is directly proportional to L1. And what is the proportionality constant? K. So E is equal to K into L1. Now what is the second condition? Second condition is both switches closed. Both switches closed. When both the switches are closed, current will flow in the lower circuit. No? When current flows in the lower circuit, definitely battery will consume its voltage. Some voltage it will consume. So EMF is no longer existing, only terminal potential is existing. So V2 is directly proportional to L2. So from this I got second equation, V2 is equals to K into L2. Clear now? Now if I amount of current is flowing in the circuit, same I current will enter into external resistor also. No? So therefore what is the potential drop in this external resistor? Terminal potential. Okay ma? What is the potential existing between A and B? That total potential will be dropped in this resistor only. No? Okay? Or just I can write I is equal to V by R. Current entering into the resistor I is equal to terminal potential consumed by this resistor divided by resistance. Now what is, when both switches are closed, what is the potential drop between A and B? Terminal potential. Who consumes this terminal potential? External resistor. In the last class we have studied, no? So total EMF of the battery is E. Out of this total EMF, battery is consuming I into small r. Remaining potential is terminal potential. Are you able to understand? Terminal potential is E minus I into small r. That's all, no? What is I into small r? Potential consumed by whom? Potential consumed by cell or battery. Understood, no? Remaining potential is Vt. That remaining potential is existing between A and B. And who will consume that potential? External resistor. Are you able to understand? So therefore I is equals to Vt divided by R, my third equation. For Vt already I have written equation, no? K into L2. So fifth equation. Now according to this equation, we know this equation, no? Relation between EMF and terminal potential is E is equals to Vt plus I into R. Now take first equation, second equation, fifth equation, substitute here. Then K, everything will get cancelled. And this is the equation of internal resistance. Okay, ma? So R value is how much? R value is L1 minus L2 by L2 multiplied by R. That is one of the equation to calculate internal resistance of a cell. Clear, no? All this you need not understand, ma. Just for your understanding. These equations you must remember. R is equals to L1 minus L2 by L2 multiplied by external resistor R. Is it clear? Now same equation I can write like this also. One more equation of internal resistance of the battery. Okay, ma? One equation is what? R is equals to L1 minus L2 by L2 multiplied by capital R. This is one equation, no? Now multiply everything by K and K. So K by K. So therefore what happens? KL1 minus KL2 divided by KL2 multiplied by capital R. Okay, ma? KL1 is nothing but EMF. KL2 is nothing but terminal potential. KL2 is again terminal potential multiplied by R. So this is my second equation to calculate internal resistance. Okay, ma? This is my first equation and this is my second equation. Okay. So depending on which data is given, you have to select any one of these equations. So values are given in terms of balancing lengths, or values are given in terms of EMF and terminal potential. Based on that, you have to select any one equation and you can calculate the internal resistance. Fine? That's it. So that completes our topic called electrical measuring instruments. Okay, ma? Okay. See this question. So this is a potentiometer, ma. Supply potential is 2 volts. Clear? And this is a cell of EMF 1.5 and there is some internal resistance for this cell also. And there is an external resistor which is connected whose value is 9.5 volts and there are 2 switches. Clear, ma? So first what I am doing, when switch S1 is closed and S2 is in open condition, null point was obtained at 76.3. It means in the first condition I am closing the first switch and this is in open condition. Then I am searching for null point and this is the null point which I got. Where I got at a length of 76.3 centimeter. Okay, ma? Now 76.3 centimeter, will it indicate EMF or terminal potential? 76.3 centimeter will indicate EMF of this cell or terminal potential of the cell. EMF only, no? Why? current doesn't flow. This lower circuit is also open, no ma? So current never flows. When current never flows, EMF remains to be EMF. Therefore, I can say EMF E1 is equals to K into L1. Or I can say E1 is equals to 1.5 is equals to K into L1 is 76.3 centimeter. I can write like this, no? E1 is equal to K into L1. Clear, no? Now what is the second point he's saying? The second point is when both the switches are closed. I am closing the first switch also, I am closing the second switch also. Both I am closing. If both I close, then I am getting null point at 64.8 only. It means this second length is there, no? This length. This length is how much? This length is 64.8 centimeter. Okay, ma? Now why length has reduced, can you say? When this switch was in open condition, null point was at 76.3, no? Now null point is only at 64.8. What is the reason? Length tagipoyindi, length has reduced. Why? Because here the potential value should have reduced. The potential drop in this wire should have reduced, no ma? Then only length also reduces. Why potential has reduced? Previously it was 1.5. Huh? Now definitely it should have been less than 1.5. Then only length also has reduced. Why? See ma, if I close both the switches, current starts flowing in the lower circuit, no? If I close this switch also, if I close the second switch also, then what happens? Current starts flowing in this lower circuit, no? Clear, no? Same current will enter into battery also, and battery will have internal resistance, no? But here internal resistance is not shown, but in the question he is asking about internal resistance only, no? Clear? So battery definitely will have some internal resistance. So when current enters into internal resistance, there will be some drop. So EMF doesn't remain to be 1.5, it reduces. Because EMF reduces, because EMF has converted into terminal potential, length also reduces. Are you able to understand? That is the reason. So therefore, when both switches are closed, clear ma? Current flows in which circuit? Current flows in lower circuit. This is the lower circuit. Current flows in lower circuit. Therefore, current enters battery also. Current enters battery also. And there will be somewhat? There will be some drop in the battery. Drop ante potential drop ayyo. Drop ante water drop, alcohol drop anukunderu. There will be some potential drop in the battery. Clear, no? Therefore, EMF no longer exists. EMF no longer exists and only terminal potential exists. Only terminal potential will be there, no? And we know that terminal potential is equals to E minus I into R. Therefore, terminal potential is definitely less than EMF. Therefore, length of null point reduces. So total concept, once again I am writing. Are you able to understand, ma? So what happens to total length of null point? Reduces, no? Because potential has reduced. Clear? And already we have calculated a direct formula, nama, to calculate internal resistance. What is the direct formula? L1 minus L2 divided by L2 multiplied by capital R. Direct formula. Just substitute it, that is our answer. Already we have derived this one, no? So therefore internal resistance is L1 value 76.3 minus L2 value 64.8 divided by L2 value is again 64.8 multiplied by what is the external resistor? External resistor is 9.5. Do this calculation, that is our answer. Okay, ma? So the answer which you should get is 1.68 ohms. 1.68 ohms. That is the internal resistance of the cell. Fine. Are you able to understand, ma'am? Clear? That's it.